You need to send me a message just to me. As you can tell, I'm horrible with the chat feature and in Zoom. So please just send me a text. I don't see it. I reply to everybody. Yeah, it's just yet another form of communication that I'll never master. So if you don't mind, just send it by text and we'll, for a private conversation, and we'll talk that way. All right.
Mr. Ritchie,
Yes.
you don't have to reply. I just wanted you to look at it. I'm sorry. I didn't know you didn't use the chat like that.
Well,
Sorry.
I should be able to. I noticed I was replying to everybody, and then I replied to a classroom over in Keysville, and it's too much for an old man.
Wait, you don't have to reply, but I did send it. It's not that big of a question.
Okay. I was
Okay.
afraid it was something between you and me, and I was gonna.
Oh no, it wasn't anything that bad. It's not that bad.
Okay. Okay.
Thank you.
Yeah, I'd be happy to stay after.
Thank you.
Be happy to, because I don't think we'll have a really long class today, because I was looking at homework assignment 2 that we're going over, and it didn't look too taxing. So we should have some extra time after class before my next class. But what we're going to go over today are what's called let me see. Box and whisker, like a cat's whisker, plots. I was going to try to write on this tablet without it sitting on the table, but as you can see, that's not going to work either. Write like a third grader. So let me get this back on the table here. Give me a little stability. Here we go. All right. Box and whisker plots. And I'll go through it's actually going to be the first one in the homework. Now, it doesn't ask you to build a box and whisker plot from scratch in the actual question, but I wanted to do it from scratch so you could see how it's done. And then that makes it a whole lot easier to answer all the questions, because all the questions are just interpreting box and whisker plots. So let's see. Maybe I should look at the actual question on Canvas. Math 245. Excuse me. And now, Anna, it may be another student asked me about a question from the first test. And when I looked at it, I see that this textbook where these questions came from uses a term that I did not cover. Matter of fact, it's a term I've never heard used in any statistics book I've used. And that is, we did things by class width. With everything, every statistics class I ever took, every textbook I ever used, they use class width. it makes one reference, at least one reference to something called class size. And it's easy to think that that's the same thing because I never told you any different, but it's actually different. So it can kind of mess you up on some of the test questions. And if it does mess you up on a test question, let me know and I'll give you credit for them. Every time I try, I get ambitious and I want to redo a class and freshen it up. There's always these little bumps, which are annoying, but we'll get them ironed out. And you'll never be punished for that kind of stuff. So, and that might end up being the problem, Anna, because I can see where a lot of students could have that problem because it's not only is it something we never covered, but it sounds almost exactly like something we did cover, but it's different. So that was unfortunate, but I was glad that I don't know if Alexis is out there, but I'm glad that Alexis asked about it and we had a little exchange about it because then I realized what was going on.
Thank you.
And thank you. So, box and whisker plot. There we go. Data description, homework 2. And this is, they actually give you the box and whisker plot here. You're not asked to put it together, but I want to show you how to put it together just so you see the process. This is the, now they call it a box and whisker plot. It's usually displayed horizontally. Let me show you. And that's why it looks like a box with whiskers. But of course, they, for some reason, put these vertically. So it doesn't look like, there you go. That's what they normally look like. And they look like a little box with whiskers on the outside. So anyway, if you would, I have it all written down already, but if you would grab, let me see, grab this data right here, you know, take a picture of it or whatever you young people do, that data right there. And these are, and then we're going to take that data and we're going to come up with this whisker plot. Now I'm going to rewrite that data. So if you don't feel like taking a picture of it, that's fine. But I wanted you to have the opportunity because I know some of you are very ambitious and like to do it for yourself too, which is a good attribute to have. That'll serve you well. I, on the other hand, was lazy and I couldn't care less whether I did it or not. So get that data, a picture of it or whatever, and I'm going to rewrite it because we have to put it in order. We'll have to put it in order. And so I'm going to need y'all or somebody to check me because, you know, putting numbers in order would be a challenge for me too, along with little mundane tasks like that.
For putting it in order, will you even count the ones that are repeated?
Yes, we'll put it, you have 20 data here. And then when you're done ordering it, you should have 20 data. So
Okay.
if you put, because that can change what the median, leaving out duplicates. So
Yeah.
you want to include duplicates and you want them to go from the smallest to the largest.
Okay. That's what I thought. I just wanted to make sure.
Yeah, that's good. I'm going to flip back over to my whiteboard and I'm going to write what I have and then we'll write some definitions and I'll take you through step by step what this, how this graph, this box and whisker plot graph, how it comes about. whoever has the dog may need to mute between the times you have questions. I love dogs, and our dog is yappy. Well, if somebody comes in, she's very loud. Otherwise, she's pretty good. I'll have to bring her down here one time and introduce you. 'Cause-
Yes, you'll have to.
Yes. But yeah,
You
this
can
is
meet my dog. My dog's with me too, but he's sleeping.
okay. Okay. Maybe we'll have a pet day.
Yeah.
My house has become like a zoo. I have, 2 teenage daughters. So cats and dogs and quail and rabbits. And
Oh, wow.
yeah, I have to take some of the blame because it gives us stuff to do together. So it's kind of fun,
Yeah.
but it probably is a few too many. All right. So I'm going to arrange my version of arranging these in order. And then,
I was about to ask, did you want somebody to tell you? But
yeah, that if you've got them,
I have them if you want them, but I can wait if not.
all right. Let me see. Let me get ready here.
Where's Alexis? I need her to go behind me.
I'm going to. I was just slower because I was talking.
All right.
I'm sick. Please
so that's
excuse
fine.
my voice.
You're fine.
And I got it too. So if you read them, then we can both check you. Thank you. Go ahead.
Okay. 2, 5, 7, 8, 8, 11, 12, 14, 20, 23, 23, 25, 26, 27,
Hold on one second here.
28.
Hold on one
Oh,
second.
am I going too fast?
Yeah, my little stylus kind of freaked out, and I have to 23, 23.
Oh, I didn't even
And then
notice you were writing. Sorry.
Okay.
3,
25.
yeah, 25, 26, 27, 28, 29,
Oh, here we go again. 28, 29. All right.
31, 36, and 42. Is that it?
Is there 20 there? Let's see. Let me check mine. There's 2 36s, aren't there?
Is it? Yes, I missed
Yeah.
one. Yes,
I have 2,
sorry.
5, 7, 8, 8, 11, 12, 14, 20, 23, 23, 25, 26, 27, 28, 29, 31, 36, 40. That's what I have too. Lexi, is that what
Okay.
you have as well?
Yeah, we have
Yes.
to add the other 36.
Yeah, after the other 36.
There we go. How's that look?
Yep.
Perfect.
All right. Now the idea of this is kind of to show another way to show the shape of the data. And mostly we're going to do this with just medians. And you might have suspected that because we put everything in order. And we kind of know that that's what we do to find medians. So here are the steps. First step, you arrange. And we've done that. Arrange them lowest to highest, just like you're going to find the median. And we are going to find the median. Then we want the extreme values, the min and max, what they call them, what I looked at, they called it an extreme value. Lower, extreme, there'll be a number there, and the upper extreme. All right, What is the lower extreme value? The
Would it be
smallest.
2? And
Yeah. Okay, go ahead.
and then the upper one would be 42.
There we go. All right, simple enough. You want kind of the min and the max, or probably a lot of different names for this. Now, that's step 2. Step 3 is the median. Well, we've done the heavy lifting already. We've put these in order. So finding the median means just finding the middle one, correct? So I'm going to draw now. We have an even number of data, so we have to be aware of that because the median will actually fall between the 10th and 11th data, because that's halfway. So we count down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, it just so happens that it falls between the two 23s. Of course, that's just luck. The way we find the median when it falls between two numbers is to add those two numbers together and divide by 2. Since these are both the same, what is the median?
Would it just be 23?
It would just be 23.
Okay.
So now we have kind of cut our data in half. Now we're going to introduce what's called quartiles. A median cuts data in half. Quartiles cuts it again. So then we have quarters. We'll have 4 pieces, 4 groups of data instead of 2. And that gets used, that actually gets used quite a bit. You may notice that. I know if you look up, if you're applying to go to college somewhere and you're like, I hope my SAT is high, or is my SAT going to be high enough to get into this school? You can look up stats and they'll say, well, the lower quartile of admitted students has this SAT and the upper quartile has this SAT. So you kind of have an idea if you're at least on the map for that school. Of course, now you have a lot of test optional things, and that's just an example. I fall back on college admissions examples a lot because my kids, I have one in my son's in his 2nd year, and I got a senior and a junior. So we're dealing a lot. We're right in the middle of all this college admission stuff. So anyway, we want to look at that top. So let's see, maybe I'll write the definition separately over here. The, well, I don't know if I need to do that. I'll just draw it when we draw it. The quartiles are the median. The upper quartile is the median of well, let me hold on one second. Let me just make sure I got this. I don't want to get it backwards. I hate when I tell you something wrong in class. Let's see. I mean, I don't think you'll understand what a quartile is right away, but I don't want to get them backwards. Let's see. Yeah, that's what you would think. It's the higher part of the data. So we're going to find the lower quartile first, just so we're working from top to bottom. So anyway, step 4 here. I'll do the lower quartile first. And we're going to look for the lower quartile. We're going to look at the, we divided our data in half. We're going to look at the half that has the smaller numbers in it. So the top half, the way we have it written out here. So looking at that that lower quartile, we got numbers that go from 2 to 23. There are 10 of them. We want to find the median of that group. And since there's 10 numbers, it's going to be between two numbers again. And it looks like it falls right there, doesn't it?
Yeah.
Now, in this case, we do have two different numbers. So what would be my median of that, of the upper, or what would be the upper quartile there?
Would it be 9.5?
Yeah. And how did you get that, Lexi?
8 plus 11 divided by 2.
Right. So if you fall between two numbers, what you do is really just find the mean of those two numbers, which means add them together and divide by 2. And that comes out to 9. You said 9.5.
Yes.
All right. So that is this is 9.5. And the value with that is that you can say that 25% of the data falls below 9.5. So 25% falls below that 9.5, and that's considered the lower quartile. So if you're applying to a university that has more selective admission, and you're like, do I have, and they're not test optional and they want to see SAT or whatever, and also GP and other things, but you can look up and see, well, what's the lower quartile of the students who get accepted there? Because if I'm not even in the lower quartile, I'm probably not going to apply, because I feel like I need to at least be there to get a serious consideration. So you need to get on the map. That's what I tell my kids. You need to get scores on the map at that school, or else you're just, or you need to pick a different school. Still all very good schools out there, but you need to pick schools that are appropriate for your level, because you want to be, you want to do well at those schools and pick the right school for you. That's just as important. Getting in over your head at school that's too difficult is not going to end well, and that's not good for you. So you want to pick a school that suits you. So try to get, I tell them you need to be closer to the mean, but at least you want to be on the lower quartile, and that at least puts you on the map. Anyway, a lot of talk there. Now let's do the upper quartile, which is, I bet you know what it is. Upper quartile. How do you think we find the upper quartile?
23 to 42.
Yep, we're going to repeat that process, but with the higher half, the upper half. I wrote this in order. When I say the upper half, I mean the higher numbers. The way I wrote them down, it looks like the lower half. So that's going to be, we have 10 numbers in this bottom half. 1, 2, 3, 4, 5. So that looks to me like it's going to be right here. Does that look right?
Yeah.
All right. So it's between 28 and 29. So what number is between 28 and 29? Exactly between. We do what we did last time, and we said, okay, 28.
I got 28.5.
That sounds very reasonable. 28 plus 29 divided by 2 And you're telling me that that's 28.5. So we've kind of chopped this data into 4 quarters, 28.5. And you can say things like 25% of the data. Let me just draw it here. 25% of the data falls below a 9.5, right? That's a quarter of the data. Does that make sense? That's 1/4 of our data that falls below that 9.5. Then we could say, how much of the data falls below the median?
Be 85%.
Well, just from that 23 and below, how much of the data is that?
50%.
Yeah, half of it, right?
Yeah.
Exactly right. So you would say, well, half of this data falls below the median of 23. And then what percent of the data? Now, believe me, the questions, go ahead. What was
Or
that?
no?
What's
Maybe
that?
75.
Yeah, very good. Now, actually, for the ones you're going to have to do on homework, I'm over teaching this. It doesn't ask you all these really particular questions, but I want you to know when you see one of these.
Thank you. That's helpful.
Yeah, I feel like when you take a statistics class in college, you need to know more because you want to be able to explain it to someone else, not just know the vocabulary. Anybody can do that, but you can go out there and somebody says, they said I was in the third quartile, or what does that mean? You say, well, you're in 75% of the people you're in with them. So that 3/4 of the people are in that same group with you. So usually that means you're doing pretty well. When you took standardized tests in school, probably not the SOLs, they would often say that what percentile you were in. And if you were in the 75th percentile, that means you were 75% of the data is in that group with you, and only 25% was ahead of you. So you're sitting pretty good then. So anyway, that's all that means. I'm going to erase my colorful little arrows here in these numbers because they're just going to get in the way. All right. That was step 4. And then the last step is to draw our box and whisker plot. And we'll draw our graph here. I'm going to draw it horizontally, but sometimes it's displayed vertically. So whatever. So we know that our minimum is 2 and our maximum is 42. So that axis we have has to go at least that far. Just like when you drew the histograms, you had to make sure you started low enough and then ended up high enough. So we're going to say, I'm just going to call this beginning part 0. That definitely includes everything. And we got to go up at least to 42. So I just said 44. Whatever. I said 44 because it was going to be easy for me to draw my little lines in between. All right, so this would be right about in the middle. That would be about 22, right? And in here, that would be 11. So this is just like a number line you used to draw in elementary school. That's a 33. And then all the numbers in between. But I got to write some of the numbers in so I can figure out where to put my dots. All right, first we need to denote our lower extreme value. What was our lower extreme value?
2.
2.
Yeah, 2 was our lower extreme. So I'm going to do my 2 right about there. And I'll go ahead and label it 2 so we know what it is. That's about where 2 is, isn't it? It's 2. And I need my upper extreme value. And what is
40
my,
Oh, sorry.
no, that's good. What is it?
42.
42. So I'm going to put that out here, right about where 42 would be. All right. And that is 42. And then the next thing I'm going to write is that let me get the, I keep fumbling around for a name. Let me check my vocabulary again. Sorry. Oh, it is called the lower quartile. So I was accidentally using the proper words. So 9.5 is my lower quartile. And I'm going to draw that in. And I might as well make it blue. And what 9.5, so that sucker is right about here. Okay, that is my 9.5. And then my upper quartile, which that's green. What was the upper quartile? 28.5?
Yeah. Yes.
Okay, 28.5. So that's right about here. Okay, so that's about 28.5. .5. Of course, if you're drawing this, you won't be doing all these colors. I'm just doing that because it's fun.
I was definitely doing it too.
I know it's, thank you for your patience with me as I try to do.
I was doing it with you. The same colors and everything.
Okay. Well, there is no rule that says the lower value has to be orange. That's me doing that.
It makes it more fun.
Yeah, it does. This is a lot of fun, isn't it? Who thought
Yeah.
math could be so much fun?
I know.
And then what is the median? That's the last one of those numbers we calculated.
23.
23. So here's our median. And of course, our median is red. Just because. All right. So those are those 5 values: the lower extreme, the upper extreme, the lower quartile, and the upper quartile. And the reason, of course, they call that the lower quartile is that's the cutoff for the lower quarter of the data. So that's all that means. And the upper quartile cuts off the upper quarter of the data. So that's what we draw. And then we draw a box, our box for our box and whisker plot. And I'm just going to be why be boring now? I've already got it so colorful. So my box will be pink And it goes from the lower quartile to the upper quartile. It should go right through that upper quartile. Excuse me, that lower, that 9.5. Pretend that goes right through the middle. You don't want to watch me struggle to draw that all over again. All right, so there's our box and our whiskers. Well, wait a minute. Before we also draw, we draw a box from the lower quartile to the upper quartile. Then we draw a vertical line through the median. So it looks like that's a terrible job, Brent. So that really goes, I don't know why I'm struggling with that. And that should be a pretty easy task. Let's see if I can slide this sucker over. There we go. All right. So we have this pink box. The left side of the box goes to the lower quartile. The right side of the box goes to the upper quartile. Then a vertical line goes through the median. So that kind of gives you a graphic look at what that data looks like. You're like, okay, that's the middle 50% of the data, but we can see that the median is kind of pushed more to one end than the other of that middle half of the data. It's not right in the middle. And well, of course, the median's in the middle of the number of data we have, but that just implies that there are more lower numbers than there are bigger numbers. There's more smaller numbers than bigger numbers. So graphically, it tells us that when we see the median kind of pushed to one end or the other, the middle 50%, you know, in that median, there's a lot more of the lower end values than there are, or they're a lot smaller than there are the upper end values. And then finally, our whiskers. Go the upper quartile out to the maximum value, and then the other side. Like that. So now you have your pretty little box, which shows you the where the 50% of the data falls, and you can see it doesn't. 50% of the data doesn't fall in the middle necessarily of the data. There's more of smaller numbers than there are bigger numbers. So when it's kind of offset to one side or the other, you can that tells you something right there. Or like, okay, half the middle half is kind of towards the lower end. There's more of us, and when I say lower end, I mean the size of the data, not the number of data. I mean, obviously the median falls exactly in the middle, but that's when we're just counting 20 pieces of data. You know, it's between the 10th and 11th value. But when we're talking about the actual size of those numbers, 2, 5, 7, 8, 8, this tells us that there's more smaller numbers than there are bigger numbers. And you can kind of see that when I was arranging that, it kind of felt like that. I thought, well, there's more of these smaller numbers. When I got up to like the 30s, there were only 3 numbers in the 30s, and there was only 1 in the 40s. But there was a bunch in the 20s and a bunch of single digits. So anyway, that's your box and whisker plot, and that's how you draw one. Now, I bet you're going to figure this out without me telling you directly, even though you've never heard it before. This is just a definition. You know, and also, I guess there is a this lower quartile is often called Q1, quartile 1, and this upper quartile, this is just vocabulary, is often called Q3, because Q2 would be the median. You know, and so those are the 3 numbers, Q1, Q2, and Q3 divide, are the 3 cuts that divide our data into 4 pieces. All right, so that's just shorthand for this kind of thing. Interquartile range. When we used range very early on when we were doing frequency distributions. So if we were doing a frequency distribution and I asked you to find the range, do you remember how you did that? We were finding class width and I'm like, okay, find the range of the data.
Just the biggest and smallest.
Yeah,
Subtraction.
exactly. That's exactly what it was. So using that idea of just the biggest minus the smallest, can you think about how we might calculate interquartile range?
So,
What? Oh,
oh,
you
go ahead.
There you go. You can go.
I mean, I really don't know. I was just saying, like, if we got it, it'd just be 40. So would you just, honestly, I don't know. Never mind.
Well,
I
I
know.
know, and that's not your fault. You don't know. And we haven't gone over this, but I was thinking maybe you could just infer from
Would
how we
it
did. Go ahead.
would it be like 42 minus 2?
No, that'll be the range.
Yeah, like that's the range.
Oh.
Like, I don't know
That's
what it
the
is
range of the
after
data.
that.
But now I'm talking about those quartile numbers. If I say, well, what's the interquartile range? You're not supposed to know this, so don't feel
Okay,
bad.
great.
So we're supposed
but,
to find. So we're supposed to figure out what the interquartile is.
Well, I'm just seeing if you could
is
infer.
it different from
Would it
like
be-
finding the range of the data, like just of all of
Yeah.
them?
Would you wait? I think I know maybe, and it's Mallory, and I don't talk much. Would you maybe? Would you add the 9.5 and 28.5?
Yeah, that's what I was.
You're
then-
close. You're very close
Okay.
now. Think of
That was my
Mallory.
guess.
Mallory, when we did the range, we would have taken the 42 minus the 2. There was no addition.
Yeah, that's
Right,
what I did.
right.
I thought-
Never mind.
So guess again, Mallory.
Maybe you
what we want to
subtract
do.
it.
There you go. There you go. So the interquart, see, I knew you guys could just with deductive reasoning come up with this. So we would use the upper quartile Q3 and subtract the lower quartile Q1. That's the interquartile range. So in our particular problem, that would be that 28.5. Mallory, you were so close, just missed this, the operation, addition instead of subtraction. 25.
And I was about to make it so complicated because I was thinking you got like the range of both of them and had to figure something out. But great.
Well, it sounds
I-
like this. It sounds like it should be complicated with a name like interquartile range.
yeah.
Yeah, that was gonna. I literally after he said it wasn't the 242, I was like, oh my gosh, it has to be the 9.5 and 28.5. Good job,
And it is.
Mallory.
There you go.
Yes.
Thank
So
you.
Thank you, Mallory, and you can talk more if you want to. I like hearing from you.
Thank you. I did say addition because when I was looking at it, I'm like looking at your screen right now, and I was looking at the how you get upper quartile and lower quartile.
Ah,
So I was
yes,
thinking add. I don't know.
I understand. Well, you weren't supposed to know. No one ever told you. So, but I was just thinking, and I was right. You guys just reasoned your way through it and figured it out. And I think sometimes when you do that, you remember it a lot better because it makes, you figured it out on your own and it kind of makes sense all of a sudden. So interquartile range for here is 19 for what that's worth. There it is. All right. So we've taken our data and through this complicated process, we came up with a picture. And that picture shows us a little bit about this data. Now, the homework questions that we're going to do are really just mostly reading Whisker box and Whisker plots. You don't have to redo a whole one of these, but now you could if you wanted to. So let's look at, and I complain a lot, don't I? I have separate complaints about some of these homework problems, but you'll hear it when we get to it. Not complaints about you, complaints about the problems. I have no complaints with you all. Screen.
Yay.
Yay. It's been a very nice class, and you guys make me look forward to it.
Same
So here, yeah, the only thing that would be better is if we were all in a classroom together. Of course, nowadays that rarely happens, but this is
I
the
know.
second best thing, to have a bunch of students that all come to the Zoom and we talk a lot, and it's a little bit fun, or at least it is for me. My idea of fun and yours is probably different. But
I think it's fun too.
okay, good. Because my daughters like to tease me about that when I talk about that, but calling it fun, sitting down and doing math. All right, so here's our box and whisker plot. That's the same one we have, but they put it vertically. So if you just rotate that counterclockwise to a vertical, to a horizontal position, then you would see, no, clockwise to a horizontal position, you would see our graph. I just hate that they call it a box and whisker plot, and then they put it vertically. The whole reason they call it box and whiskers is because it looks like a cat a little bit. So anyway, all this question asks is, it didn't even ask you to draw that. They give you the plot and they give you the data, but what they ask for is the interquartile range. What would that be?
Sorry, can you ask that again? Sorry, I was writing down.
Are you guys seeing my Canvas screen now?
Yes. I
Okay.
was
Yes.
just writing down from
The actual question in all this is down here. They
It's
give you the
19.
data, they give you the graphs. Yeah, exactly. They
Yeah.
give
But
you
why is it a decimal?
why is what, oh, 0.0?
Yeah, like why do they have instead
Yeah,
of
well,
the regular?
yeah, a lot of what's a good question. A lot of these test banks are generated, the questions are generated through algorithms, and they'll set when they program it, and then the computer program itself like puts the numbers in, and they'll set to like, they always want to see one decimal place. So the
Oh, okay.
computer only knows what you tell it to do. So if it's 0, they still write it down. Normally, we don't do that. So it doesn't mean any different. Yeah, 19.0 or just 19 would be perfectly fine. So there you go, interquartile range. So we got that. Now this part of class is going to go really fast because when I was looking at these, they became really easy to see. All right, here is a similar looking box and whisker, but not the same. They want to find the interquartile range again. So tell me how I would calculate this. What minus what?
30.5 minus 10.
There you go.
I cannot believe you. No, I'm just joking. But you really made us do all that.
Yeah, for this.
So-
Well, the nice thing is this problem looked easy right away because you know what all those jumbled up numbers are.
It's
know,
very true.
Instead of a picture and saying
Yeah, I'm
this
glad we
one
did it.
minus this one. So you just, but you are right. I told you I was going to overteach really a lot today.
It's
And
okay.
that's
I'm
what I
not
did.
mad at it. It was easy to understand.
Right. That was my point anyway. And to entertain myself somewhat. Okay, so 20.5. There we go. I just knew when I first saw these problems that some of them were going to ask you to draw it. And then by the time I got to the end, I thought, none of them asked. We just read them. All right, so there's that one. Let's see what else they ask here. All right, these are the ones that made me grumpy again, because they put some values so close together, it's hard to distinguish, especially for an old man. Maybe you would be better at it, but you may have to, when you're doing problems like this, of course, we're gonna do this in class. When we take it on the test, you may have to zoom in on your screen, and I'm gonna draw a vertical line so I can tell which number is bigger than which number. So, and this question, you'll see what I'm talking about. It says, suppose automobile insurance gave annual premiums for top rated companies in several states. The figure below shows box plots for the annual premium for urban customers in 3 states: California, Texas, and Pennsylvania. Which state offers the lowest premium? So just the absolute min. So that'll be the value all the way to the left side, right? Doesn't our smallest value show up on the left side of a box and whisker? Like when we were doing back to ours here, the left-hand side of the left end of the left whisker showed us where the smallest one was. So that's where the 2 is. So we want to determine which one of these whisker plots we're looking at has the smallest value. Unfortunately, these knuckleheads made them so close together that you really have to be careful, because obviously it's between California and Pennsylvania, right? But it's hard to see on the left-hand side of that whisker which one of those goes more to the left. And that's what this is me complaining. I told you I was going to complain.
Is it California that's more to the left?
Yeah. Let me draw a vertical line and we'll find out. I can get a perfectly vertical line here. That feels pretty good. And I can slide it over here. Am I perfectly vertical?
I think you're close enough. I think you can tell.
Yeah, but the bad news is I think that the answer they want you to put is Pennsylvania. I don't know why
Oh,
they made
what?
this. I know. Maybe I'm
Oh,
not
I
vertical.
thought you meant the other line. Okay, I didn't even notice that. Yeah, I can't tell.
I know. I don't know why they had to make them so close together. And they made them so close together, it doesn't even look. Alexis, when I first looked at this question, when I was going through, I thought it was California. But then I
Yeah.
looked at the answers and they said Pennsylvania. So I'm obviously going to have to do something. I'll have to look on the test and see if they did anything else stupid like this. I mean, they could have put the one out a little bit further so you could tell,
Yeah.
but this is what they did. And it's really annoying, but pretend if you would, for our sake, that let me draw this. And maybe I could edit the questions before maybe that's what I'll do. Try to, well, I don't know if I could do it. Yeah, they could have just.
So
put
did they not mean to make the California one closer?
Yeah, well, I don't know what they meant to do. I'm guessing that if you zoomed in close enough, that they made this graph much bigger, and maybe there is a 1 or 2 difference. But when they shrunk it down so small, you couldn't tell anymore. And is it possible the vertical line that I drew earlier was not perfectly vertical? So it was almost indistinguishable. So this thing's kind of hard to tell. That feels vertical.
That looks good.
But anyway, we shouldn't be having to have this conversation about this. It should be obvious. Shouldn't do that to us. Yeah, that still looks like California.
Yeah.
So I'm going to have to address this. So I would say, I would agree with you that, but the homework, actually, let me finish this and then I'll pull up the version where you can see the answers.
Okay. So
And
for the
then- so you
homework
get 'em right.
assignment, should we put Pennsylvania or are you going to change it?
Well, no, I'm going to pull up before we finish class, I'm going to pull up the version of the homework assignment with the answers, and then you can write in the answers, which is, so annoying. I mean, it was really fun up to this point, but then they just did something stupid like this. So anyway, from what we're seeing, it would be the one that has the whisker that goes furthest to the left. And what I'm seeing is California has the lowest premium. Now who has the highest premium?
Texas.
Right. See, why couldn't they do that? You can look at it and you can compare all 3 and you can make that decision easily. So the lower one is the problem one. We're going to look at the answered questions before we're done. And so you don't miss them on the quiz. And then I may try to, before I release the test, I might try to fix the graphics a little bit. That may be a little, I may not be able to do that, but we'll see. Anyway, annoying. It looks like just answered the way we think it should be. What we're seeing. California is the lowest, Texas is the highest. But I'll show you what to answer on the homework. All right, here we go again. And as you can see, they once again put Texas and this time Texas and California on the left-hand side, very close together. But what they want to know is who offers the lowest premium and who offers the highest premium. What would you say based on this?
I would say California has, well, actually, no, Texas maybe has the lowest, and then Pennsylvania has the highest, maybe.
Yeah, Pennsylvania obviously has the highest. We can say that. It does look to me like Texas is the lowest. But here again, it shouldn't be such a challenge to tell.
And honestly, as long as you know like one or the other, like if you can tell like which one is highest, it'll help with the answer choices.
Does it help?
Just a little.
Because the last one, both options were there, so you would miss it if you didn't get it. Texas has the lowest. So we're saying it looks like Texas is the lowest and Pennsylvania is the highest. Yeah. Yeah, you're right, Ayana. That kind of helps us decide on this one. Texas lowest, Pennsylvania highest, right there. But it shouldn't be an issue. And that's why it annoys me. This is awful. Every one of them's like this. Well, this is better. We don't have to worry about the extreme values. Now the question is, we're looking at this box and whisker plot, which state has the highest median insurance premium?
Would that be Pennsylvania?
Pennsylvania.
Yeah, I said
Yeah.
Pennsylvania too.
Yes. And how do you know that?
It's closest in the middle.
Yeah, that middle line is our median, right? Isn't it? That middle line is
Yeah.
our median. So these are the median, like that's the Pennsylvania median. This is the Texas median. And here is the California median. So when we ask which is the highest one, that one's easy to see.
Did you mean to skip question 4?
I did not mean to skip question 4, so I'll go back.
Okay.
Let's see.
Oh, he skipped. Wait,
Did I skip one?
did you skip it? I thought I have an answer.
No, he didn't skip it. We didn't do 3. Number 4 is Texas is the lowest. Pennsylvania is the highest.
Oh,
3 was the one he said he has to like go back
Yeah.
and look at, I think.
oh, can you go back to 4? So I can just take
Here's
a picture of it.
3. I actually answered both. So there's 3.
Yeah,
Well,
I answered mine
yeah, I'll
too.
be careful
Yeah.
taking a picture, Alexis, because I'm going to show you the questions with the answers in. Those are
Okay.
that's what you want to take a picture of.
Okay.
So you put in the answer that they want, so you get 100 on your homework question.
Okay.
You obviously know how to do this. That's not the issue. The issue is their stupid graphs.
So, but the 4th one we did correctly, right? Or do you not know yet?
This is the 4th one.
Yeah.
Texas is lowest. I think that, and it looks like that to me. I would say
Okay,
that's
so-
the correct answer. Hopefully that's the same answer they have.
Okay.
There's a difference between the right answer and the answer they have. So I apologize for that, but it is what it is. Then we did that, the highest median. That was, you guys got that right away. Who has the smallest range of premiums? Now, this is just the range. Which we-
Pennsylvania.
Maybe Pennsylvania.
Hey, very good. And how did you get that?
It just has the least amount of like range. It's just shorter than all the other
Yeah.
ones.
Right. The whiskers are shorter
Yeah.
because the whiskers go from the minimum value to the maximum value. And we know that the range is calculated as maximum minus minimum. So there you go. Pennsylvania has the shortest whiskers. So that is the smallest range.
Could you go back to question number 6, just so I could take a picture of that real quick? I'm sorry.
Yeah, hold on. Getting spammed right here. All right. Here again, I would hold off taking pictures. We're going to
Okay.
go back through the questions with the answers. Those are the pictures you should take.
Okay.
So here it is, but don't accidentally look at one of your pictures and use that. We're gonna look at them with the
Okay,
answers.
thank you.
And those are the pictures I would rather you take. All right. And this one was what? Smallest range you got. Oh, this is a different question though. Oh yeah, this is a similar question, but the graphs are different. Which one here has the smallest range of premiums?
Texas.
Yeah. There we go. And okay, who has the smallest interquartile range?
Texas.
And how did you get that?
Oh, go ahead.
It's just
I
like
agree with you.
the interquartile part is smaller than all the other ones.
Right. The left-hand side of the box, it's got the smallest box, right?
Yeah.
And because the left-hand side of the box is the lower quartile and the right-hand side of the box is upper quartile. So what it comes down to is which state has the smallest box in the box and whisker plot. And I think that one's pretty clearly Texas. All right, now they're going to tell me.
I got an 87. So
Yeah,
I think it's.
I think I got 100 because of that one question. But anyway, let me show you with the answers.
Oh wait, no, I got number 3 wrong, but that might have been my fault.
Well, here they are. Here now, this is the picture. These are the pictures to take, Lexi, and
Okay.
but be careful because they're numbered weird. This says the first question here. It says question 21. It says 21, but it's the first question. So take a picture of the whole question and don't count on the numbers. It says 21 because it was the 21st question in the bank. You know, it's not.
Okay.
I think
I think I got I think I have it all because for the question that we said was wrong, I just wrote down that what it actually
Okay.
was.
Well, let me show you real quick because there's not that many. Here was the first question that we did all that work on, and it was 19. We knew that one. And you can see the answer there. Do you see where it says correct answer?
Yeah.
Okay. Just so you guys, so be careful. These are the answers to put in so you get a good grade on your homework. And then I'll try to make sure there's no misleading ones on the test. If there's some that are close like that, I might just delete them. That would probably be the thing to do. Okay, here's the second one. That was no problem. Correct answer 20.5. We got that. Here's the third one. You need to take a picture of that. This third one, Pennsylvania, this was the one, I think.
Yeah.
They say Pennsylvania has the lowest. But when we drew our line.
What I got wrong.
Yeah. But you know, on this pit, I don't know. It almost looks like, but it shouldn't be that hard to tell. So anyway, when you enter it in your answers to get your grade, make sure you select that's the third choice. Pennsylvania has the lowest and Texas has the highest. This one, Texas has the lowest. Pennsylvania has the highest. And I think that one you can kind of tell, but it's still really close. So be careful. Texas has the lowest. Pennsylvania has the highest. I can see this one a little better. It was really just that one that was terrible. They shouldn't make them this close. All right, then the next question, who had the highest median? You knew that one, Pennsylvania. There you go, snap a picture if you will. And if you do the homework and miss one of these questions because of this stuff, just text me and I'll fix your grade. You know, I'm not gonna, and then I'll fix this assignment before next semester.
Mr. Ritchie,
Yes.
did you fix the first homework assignment?
In the first module,
No, in this module.
we went over it in, what was I gonna, remind me, Elizabeth, what was I gonna fix?
You were going to fix one of the questions because I did it and I got one wrong. So I don't know if you went back and fixed it or I just wrote down the wrong thing.
No, I'll
I
check it.
thought we did the last one together.
Yeah, so I mean, the last homework assignment, which was assignment 1 in this module, we did in class. And I posted the video of that. In the first module, I just fixed everybody's grade, the first assignment in the first module. So anyway, Elizabeth, just text me with that issue and you and I can discuss it just between the two of us.
Okay.
Thank you. Suppose who has the smallest range? We said the Texas, the Pennsylvania box. I don't know. The smallest range of premiums. Oh yeah, we said Pennsylvania had the shortest whiskers, so there's that one. And then this one, the smallest range of premiums, we said Texas because it has the shortest whiskers. And there that is. So if you don't get all this, the video will get posted sometimes in next week. So don't worry about it. You can look at it again and see what we're doing. The smallest interquartile range, that would have been the smallest box. And we said Texas, and we were correct. So really, I guess it only came down to 1 or 2 questions. But just be careful what answers you put in. And if you put in something and it was one of those questions, just text me and I'll fix it. And then I'll go through the test before I make it available, and maybe delete any question that's hard to determine. So we don't even have to. We shouldn't be spending all our time discussing something like that. So anyway, that's it for box and whisker plots. And the test is the next thing. I have a little work to do on it. So I'm not going to make it due this Sunday. I'm just going to make it due next Sunday. So you have plenty of time to work on it. So whatever that is in October sometime, I'll put in for the due date of tests for module 2. And I'll get it all fixed up first. And as always with these tests, you know, if you're a few days late with them, it's not going to, it might tell you you're late. It might scold you, but it's not going to do anything to your grade. So don't fret about it, but don't wait too long.
I have a question. Well, it's kind of a future question, but
All right.
is our exam going to be like cumulative or is it just?
There is no exam.
Okay. I didn't know if you gave one or not, because my other class, they do like the last test is considered our exam. So
yeah, we could probably say that. That's probably what I tell the bosses when they insist that I have a final exam. I'm like, oh, okay, just the last test. But they're all weighted the same. So it's the same as not having a last, not having a final. So we just have one test per mod, a couple, 2 or 3, 1, 2 or 3, a few homeworks per module, and one test per module. And then that's enough stuff to do. And then no cumulative final exam or anything like that. Okay.
all right. Thank you.
All right. Well, thank you all. I really enjoyed it, and I appreciate you all, and you make it fun. So
Yay, thank
Since,
you.
since I'm stuck at home, it's nice.
Thank you.
All
Thank
right,
you.
y'all. And
I'm not
Ayana,
leaving yet, but thank you.
all right, so I was gonna say, Ayana, stick around. We probably have about 10 minutes because I got a 1:30 class. So,
I
Okay,
have,
I
um,
don't have
I
that
was
much.
just, can I tell you one thing real quick before we
Yeah.
leave?
sure.
I was just gonna say, Wednesday, I might be a few minutes late because my boss scheduled me to work for the morning instead of the afternoon.
Okay. Well, you just get here when you get here.
Okay,
And
so
you
I
can always
just might
watch
be a
the
few minutes
recording
late.
later. All right. Thank you.
Okay.
All
You're
right. See you.
welcome.
All right, everybody. We'll see you
Bye.
all later, and I'll just hang around in here. If everybody has a chance to go. And you and
Okay.
I can talk.
Bye. Have a
Bye,
great
everybody.
day.
Thank you
Bye.
all.
Bye, y'all.
All right, Ayana. I don't think Alex is. He probably walked out of the room for him. Oh, there he goes.
Oh,
Bye,
that was
Alex. Let me
okay.
get rid
I
of you.
literally, it's not like a big question, and like I don't need like I just want to show you and like see. Can I share my screen or no?
Yeah, I need to.
I think you have to like give me
Let me
permission.
remove.
Yeah, it's super quick, just so that I know like I'm not doing it totally wrong, I guess.
All right. Let me just see here. Let me just remember how to do this. And let me stop the recording. Okay, there we go. Stop recording.